thumbnail thing because I don't care. I don't want it. Okay, we're live. Boom. So y equals x squared plus 4x plus 5. Yes, the camera is pointed in the right direction. I didn't bump it. Okay. Actually, it does look like it got bumped. So there we go. So we've got one x squared tile, which has dimensions x by x. We have 4 x tiles. Since I'm making a square, I'm going to put 2 on each side. These have dimensions 1 by x, which makes this x plus 2 by x plus 2, which means that once I turn this into a square, it is going to be a square that is x plus 2 squared. However, it is not a square. It is a, well, it's a not square. In order for it to be a square, I got to fill in that. The way I fill in that is I recognize that this is a 2 by 2 square, so I need to add 4 unit tiles in order to make it into a square. Now, this means, and at this point I'm ignoring the plus 5 because I find it much, much easier. I've told you before there are explanations on the internet and in other textbooks that will tell you to take the plus 5 and use part of it to fill it in. Well, but fine, then what if it's a negative? It's a pain. It's much, much easier to put the plus 5 off to the side and say, I'm just looking at this. Completely ignoring that. Now, here's the thing. This is x squared plus 4x plus 4. But I don't have a plus 4, so I added 4, which means that I need to subtract 4 to balance it out. I'm adding and subtracting the same amount to fill in my square, but keep my equation in balance. And when I bring that minus 4 down, I can now combine this with that. Okay? My new equation is y equals x plus 2 squared plus 1. And why do I do this? Well, because I immediately can look at this and say, aha, the vertex is at negative 2, 1, which I did not know up here. And now I can do a quick graph. So let's talk about quick graph very briefly. Quick graph. When I think about a quadratic, if I make a table, I know that 0 squared is 0, 1 squared is 1, but so is negative 1 squared, 2 squared is 4, but so is negative 2 squared. I can graph quadratic by just saying, there's my vertex at 0, 0, and if I go out 1 in each direction, I'm going to go up 1. And if I go out 2 in each direction, I'm going to go up 4. Boom, I've graphed a quadratic. I don't have to look at my calculator. I don't have to try to figure out which points. I've got the vertex and I know it's 1, 1, 2, 4. If I want to go further, 3, 9, 4, 16, 5, 25, whatever you need for the size of the graph that you're making. Guys, I'm going to call this a quick graph, and I'm going to ask you to make quick graphs all the time as we're talking about this stuff.
Yeah, I also got that because I also tried joining you.
Okay, do me a favor, take a screenshot.
I had to do that on Chromebooks. I don't know okay.
It's at the bottom of the screen on the bar. There's an option, a pen. You can click it and it lets you screenshot.
Oh, no way.
Capture screen. Do me a favor. Send me that. Shoot me an email.
I might have to. Might be something to do with the permissions on the.
Yeah, that's what I. It's awesome.
Yeah. Well, this is why Mr. O'Brien was here earlier, is because we're trying to figure out Um, People have been able to, but not able to access the actual videos that I've been making, but we can't figure out why. Sometimes people can and sometimes people can't. And now we're apparently not able to access the live stream. So that's useful knowledge. And if I can send that to him. It may be because I don't have it set up as video for kids.
Yeah.
But if I make it for kids, then you can't have the chat feature, which means that if you're at home, you can't ask questions. And so I was sort of hoping I might have to change that. So, all right. Thank you for checking, and we'll have to see. Are you looking on your phone to see if
Yeah, I was working on my phone.
it's live streaming on your phone? So it's definitely a problem with the Chromebook. So okay, I'll ask Mr. O'Brien, and maybe he will know. All right. So good to know, but at the very least, we still got a recording, so there's that. So guys, this is a quick graph. A quick graph is knowing the pattern of a parabola, which is starting at the vertex and going 1, 1, 2, 4, boom, you got a graph. And since in this case, the vertex is at -2, 1, I can still do the exact same thing. I can go to -2, 1 and say, well, there's the vertex. But all I did is take that parabola and slide it 2 to the left and up 1, which means it's up 1 over 1 and up 2, over 2, up 4, and boom. There's the graph of this parabola. The idea here is that if we can just get to where this kind of work is routine, we can then go do the interesting stuff that required us to have the graph. And we don't have to spend 20 minutes coming up with a graph and figuring it all out the hard way. We just go bang, 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 got a graph. Now, let's start using the graph to do whatever it is we wanted to do. Remember that math has a point. It's not just things you learn in class, but you're trying to solve some kind of problem. And the problem isn't write this in vertex form and get a graph. The problem is something interesting. But you got to get through that what we call grunt work in the military, because it's like in order to get to where do the interesting part. Okay, so any questions about this? Okay, let's have you guys do one. Your turn. Ryan, did you know my email to send that to me?
Yeah, it's good.
Cool. Y equals x squared plus 10x minus 3. I want you to write it in vertex form. Tell me what the vertex is and draw a quick graph. And don't forget, lots of graph paper back here. If you're writing on line paper and you want graph paper, please help yourself. Hey Ryan, how did you get to the live stream? Did you just go to my YouTube channel and then click on the live stream?
Yeah, on my phone I just searched up genre game.
Okay, cool. And did it open up my channel on your Chromebook, but then it wouldn't let you look at the live stream?
Yeah, like you can watch the videos.
Okay. Do we need more time? We good? Cool. I'm still trying to organize. Because now I have twice as many classes that I have to have little cups for. You guys know, you know what Pavlov's dog is? Pavlov's dog. So Pavlov's dog was a series of experiments on autonomic reactions. And autonomic reactions are reactions that you can't help. For example, think about what happens when you smell something bad. You scrunch up your face. Almost everybody does. What doesn't make it smell less bad? So there's no good reason to scrunch up your face, but we do it. It's just, it smells bad. So Pavlov did a bunch of experiments, and what he did was 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. There we go. What he did was he had a dog, and he would ring the bell and then give the dog its food. When the dog saw the food, it would start drooling, and then it would run over and it would eat the food. After he had been doing this for a month or so, he would just ring the bell and the dog would start drooling even though there was no food there. And so what he had done is he had associated bell with food, and even though there wasn't food, the dog would just automatically drool because that's what the dog did when there was food. So what I'm hoping, this is my own little multi-year experiment, is that I go like this and I ask you a math question, and 10, 15, 20 years from now, you will hear that noise and you will think immediately, someone's going to ask me a math question. And I think that would be awesome if it worked. Brooke, what's the vertex form of the equation?
The vertex form?
Yeah, vertex
Okay,
form, this form right here.
I got y equals x plus 5 in parentheses squared minus 28.
We all good with that? Okay. Where's the vertex, Tyler?
-5, -28.
-5, comma, -28. Is this an annoying one to have to draw a quick graph of? Yeah, I didn't really plan very well ahead on that one. But hey, there's -5, there's -28, there's the vertex, and I go up 1 over 1, I go up 2, or over 2 up 4, I go over 3 up 9, and eventually I get a parabola. All right? Cool. Let's do the next one. Because the next one, I said it would be easy, medium, hard. So medium looks like this. My equation is y equals x squared minus 7x minus 3. Now, why is this medium? Because I take my x squared, there it is, boom, x by x, and I go to split that in half. And if I have algebra tiles, I can't split it in half. But since I'm just imagining algebra tiles, it turns out I could go 1, 2, 3 and a half. You guys notice that that's a minus because these are negative tiles. And then here I go 1, 2, 3 and a half. It's not actually that hard. You just gotta deal with fractions or decimals. If you wanted to, well, I'll show you in just a second. I'll show you the fun, easy part in just a second. Now I need to fill in this to make it an actual square. And of course, this is negative 3.5 by negative 3.5. So notice that it doesn't matter. Once again, we're still adding. Just to make life easy, I memorize all the multiplication tables through 35, and so I know that's 12.25. Yeah, you know that elementary school stuff where they only make you go to 12, but then like the smart kids go to 17 or something? Yeah, I went to 35. I have an IQ of 876. I'm kidding, that's not even a thing. And I didn't actually. What I did do is I have paid attention to the perfect squares, not the whole multiplication tables, but knowing that 35 times 35 is 1225 comes in useful. 25 times 25 is 625. 15 by 15 is 225. And so I just sort of try to keep track and pay attention to some of those. And then when they pop up in math problems, I know the answer. So what do I need to do? I need to subtract 12 and a quarter from that. You guys are also comfortable with the fact that I didn't have 35 times 35. I had 3.5 times 3.5, but that's just 2 less decimals. So there you go. So let's write this. We've got, oh, I want blue. Y equals x minus 3.5 in parentheses squared minus 12.25 minus 3 is minus 15.25, which means that my vertex is at positive 3.5 comma negative 15.25. And you can actually do a quick graph on this one fairly easily. It seems like, wow, that's awkward, you know, what am I supposed to do there? But the pattern is still exactly the same. So if I'm looking at this graph, so let's just do the fourth quadrant. I've got 1, 2, 3, 4. So there's 3.5. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Which means that 15 and a quarter is going to be just below that. So 3.5, 15 and a quarter is right there. All right. So there's 3.5 comma negative 15 and a quarter. Well, when I go out 1, I'm just going to a 2.5 and 4.5. So my next 2 points are going to be here and here. And I'm going up 1, which means I'm going to be at negative 14 and a quarter. It's not really any more difficult, except that when I look at my graph paper, I've got to remember that this was a quarter below. So when I go up, I'm also going to be a quarter below. So there's 2.5, 14 and a quarter, and 4.5, negative 14 and a quarter. And then same thing with the 4. I'm going to go over 2. So that takes me to 1.5 and 5.5. And I'm going up 4. So I'm at negative 11 and a quarter. It's really easy to graph that stuff. It's going to be a little more approximate because you're putting a dot at a quarter. But as long as you have graph paper and you're not just graphing on a big blank screen, it's actually really, really easy to do. All right? Question? Your turn. Y equals x squared minus 9x plus 6. Brian,
Yes.
give us an equation.
Y equals x minus 4.5 squared minus 14.25.
Cool. Ooh, look at that. 45 squared is 2025. It's true. I used to run long distance, like 12, 15 miles. And one of the things I would do to keep myself entertained was I would double numbers in my head until I lost track, and then I'd start over again. 2, 4, 8, 16, 32, 64, 128, 254, 512, 1024. And I would just do that till I lost track of the digits. And then I would just start over again. 2, 4, 8, 16, 32. Man, I could get into the millions. It was awesome. It was so much fun. Better than just running along for 15 miles. Cool. Vertex. Obviously 4.5 comma negative 14.25, and we won't replicate the quick graph up here because I want to move on to the next fun part. The hard one. And guys, the only reason this is hard, oh, I didn't mean to do that. Shoot. Well, I wanted to keep that. The only reason this is hard, the only reason I call it hard, is because you end up having to keep track of a lot more numbers. So here's the example I've got. Y equals 3x squared plus 10x minus 6. So there's a couple ways to think about this one. First of all, let's look at algebra tiles very briefly, and then we will never talk about algebra tiles again. You're more than welcome to draw them if it helps you keep track. But if I want to draw this as algebra tiles, obviously I can't make one square with 3x squared tiles. If I try to do that, what I get is 2x here and 2x here, which is fine, except that then I have to add an x squared tile to make that an actual square, but that means that I have to subtract x squared on the outside. And so when I go to write this as, I'm ignoring the 10x and the minus 6 for now. When I write this, what I get is that this is 2x all squared minus x squared, which is in vertex form. So it's useless. It's absolutely useless. I can extend this by saying, let's put 5 of these on each side. 1, 2, 3, 4, 5. 1, 2, 3, really? 3, 4, 5. So there's a plus 5 and there's a plus 5. And what do I need here to fill it in? Well, what I need here is I need 5x and I need another 5x, which means that now not only do I have a minus x squared out here, I also have a minus 10x. And so now my vertex form looks like this. 2x plus 5 all squared minus x squared minus 10x. And then, of course, I've got plus 25 here, and I got minus 25 out here, and that part's fine. And so I got minus 31. Everything I just did is correct, but useless. You know, it falls under the, oh, I can divide everything by one category. Okay, why? Because then nothing changes. So what good did that do you? I did not get a useful form of the equation, even though it is a correct form of the equation. So what I have to do, and you guys know this, but I just, sometimes it's nice to just have the visual of why I can't do that. What I got to do instead is I'm going to make 3 identical squares. I'm going to make one square, and I'm going to make a third square, a second square, and I'm going to make a third square. And since I started with 10 of these, each one gets 10/3. Agreed? Divide the 10 by 3, and that's how much each one gets. So I've got 10/3 x for this, and 10/3 x for that, and 10/3 x for that, which means that now I have to split that in half. You see why I say that this is why this is the hard one, because there's a lot of keeping track of all these fractions. And so what's half of 10/3? Well, there's 2 ways to look at it. It could be 10/6, or it could be 5/3. Doesn't really matter. So what have I got here? I've got x tiles. And I'm not going to draw the individual x tiles because it gets a little silly. But I know that this is x plus 5/3. And I know that this is x plus 5/3. And this is going to be x plus 5/3. And this is going to be x plus 5/3. And this is going to be x plus 5/3. Oh gosh, I'm getting bored. Now, what? Well, here's why I left it as 10/3 per and then 5/3 on each side. Because I could, in fact, here, let's do this. Let's make this one 3.33x, which I already hate because it's a decimal that I had to round off. And let's make this one 1.67. Already, do you see the problem with using decimals? This is not 3.33. It's 3.33 if I round it to 2 decimal places. And this is not 1.67. It's only 1.67 if I round it to 2 decimal places. I've just made my answer wrong. Close, but wrong. So I really like these better. Now, why else do I like that better than this? What's 5/3 times 5/3? 25/9. Quick, what's 1.67 times 1.67? And don't say 25/9. I know. I jumped in there. I knew where you were going with it. I don't know what 1.67 times 1.67 is. I'll be honest with you. In all my days of trying to memorize perfect squares, I never got to 167 squared. So I don't know. I could figure it out. I could get out my calculator, and the answer would be roughly, because we would have to round it again. When I square that, it's going to have a bunch of decimals. And then I'm going to have to round it off again, and it's getting less and less accurate. What's that?
That's 4.
4 decimals. So I'm going to round it, because I'm probably not going to write 4 decimals on there. And every time I do that, my answer gets less accurate. And I needed a calculator, or I had to spend 5 minutes doing the long multiplication. 7 times 7 is 49. 9 carry the 4. 7 times 6 is 42. Plus 4 is 46. 6 carry the 4. 7. Takes forever. And it took us all of like 1/8 of a second to say 25/9 when I asked the question. Fast and accurate. So, here's the next part. Do I have to draw all 3 of them? No, they're all the same, right? So why not do this? Just save myself even more time. So what have I got here? I've got x plus 5/3 squared minus 25/9 3 times minus 6. Doing a little simplification, y equals 3 times x plus 5/3 squared minus, hey, what's 3 times 25/9?
75.
It could be 75/9. I could be simpler. Because 9 is 3 times 3, right? Wouldn't that just be 25/3? And the nice thing about 25/3 is I also know that that's 18/3. Should I back up? Yeah. Y equals 3, x plus 5/3 squared minus 43/3, which means that my vertex is at negative 5/3 comma negative 43/3. I have a stretch factor of 3, so my quick graph, yes, this is not an easy one. Starts here, but instead of going up by 1, it's going to go up by 3. And then it's going to go up by 12. And then it's going to go up by 3 times whatever it would have normally gone up with. All right? Questions about that? Your turn. You do not have to do a quick graph. But I do recommend that you stick with fractions instead of decimals. Y equals 2x squared minus 7x plus 2. Uh-oh. 3.5 and 3.5 makes 7, but you've got 2 of them. Really?
Decimals inside fraction.
I mean, it's not a rounded decimal.
Oh, that'll get you kicked out of the math community in a heartbeat now. Forget the square. That is your square. So what could you do to have that not be a decimal instead of fraction? Just looking at it. What's an easy fix?
A fraction and a fraction.
Maybe. What could you multiply top and bottom by that would make that not fraction decimals at all? And when you do that, there's a fraction and fraction technically. So what are you multiplying there?
2.
So now you've got 7/4. There's a fraction. Fraction 7 divided by 2 divided by 2 is 7/4. 7 divided by 4. question for you. 7/2 and 7/2 is 7, right? But if you do that twice, you're gonna have 14. Because you've already used all of your x tiles, but you only made one square. So, how many x tiles in your picture? Wait, what? No. How many x tiles? You got 3.5 there, and you got 3.5 here, right? That's 7 x
Yeah.
tiles total. But if you're gonna double it, that means you need 14 x tiles to do what you've drawn.
Wait,
So you've
I
used,
thought you were supposed to divide that by 2.
yep, and
because you have
then make a square with what's left over.
that. Right,
So you gotta
So
divide
I
by 2
divide by
twice to
2.
make your square.
so I divided 3.5 by 2, and I got 1, 4.
3.5 divided by 2 is 7/2. Did you do 2 of those?
No.
1 of those. So just that last number. Two of those, right? And then add 1 of those back in. So 98/16. And then you gotta get rid of the 2 that you started with. Okay, so here's the problem I have. I see where you're going with this, but do you agree that that square takes 7 x's? 3.5 on either side? But if you're gonna make 2 of those squares, that means you'd actually need 14 x's. So you got twice as many x's in that parentheses than you actually have because of the 2. All right, guys, let's take a quick look at this. And I'm gonna walk through the steps on this one because it's the hard one. So why not? Because here's the mistake that I see over and over and over again that we sort of got to get past. Y equals 2x squared minus 7x plus 2. I'm going to make 2 squares. I can't put 7 halves on either side. Because if I do, this is half of 7 and that's half of 7, which means these two together make up 7. But I'm going to make 2 of them, which means I would need 14 x's. I have to divide that by 2 and then divide it by 2 again. When I make the squares, I have to divide by 2. Before I can start making squares, I got to divide by whatever that leading coefficient is. Now, again, why am I doing this as a fraction and not a decimal? Well, half of 7 is 3.5. So when I make my square, I could say, well, half of 3.5 is 1.5 plus 0.25, 1.75. Agreed? And I'm making 2 of those. But see, now I've only used 3.5 for one of them, but when I double it, I've used 7. But now I have to figure out what 1.75 squared is. And again, I haven't bothered to memorize the times tables up to 175. You're just making your life more difficult, harder and harder and harder to do this, more and more decimals. By the way, we never write decimals in fractions. And we definitely never write them like that. the pieces are of size 2 and I have 3.5 of them, that's actually sort of okay. It's just not done. The pieces are size 3.5 and I have one of them. What? What's 1 3.5 of a pizza? So how much pizza do I have? I don't know. At least I know that I cut the pizza in half and now I have 3.5 halves. But
I'm so lost.
that's what fractions mean. The bottom number tells you how many pieces you cut it into, agreed?
Yeah.
So there's a pizza. Each of these is 1 out of the 2 pieces.
Okay.
Each of these is 1 out of the 4 pieces. Okay, cut the pizza, go. How do you cut it into 3.5 pieces? I don't even know where to start. Complicated, right? We never do that because of that. So let's go back and redo this, and the heck with these stupid decimals, because decimals are the tool of the devil. This is half of 7 halves, agreed? I cut the 7 into 2, and then I cut it into 2 again. Which means that this, quick square person, go.
Quick square person. Oh,
Go.
it's 49 over 16.
Bam! 49 over 16. She's on fire. And now I'm going to double that, which means that I've got x minus 7/4 all squared minus double that is 98/16 plus 2, which is 32/16. And now I can just combine those. Because when you get good at fractions, they are so much easier than decimals. Now, there's lots of good reasons for decimals. There really are. I mean, decimals are nice for knowing, if I told you that I had, 98/16 of a pizza, you'd be like, what are you talking about? I don't even know how much pizza that is. But if I converted it to a decimal and I said 2.5 pizzas, I messed up 2.5, but whatever it is, then you'd be like, oh, I can visualize 2.5 pizzas. I can't visualize 98/16 pizzas. So there are good reasons to have decimals. So, all right, here's the deal. Wait, oh, this is this day. See, I'm already confused. I was just wishing it was Thursday. We're done. I am not going to have you, I think we'll do the worksheet tomorrow. So tonight, don't do anything. I'm going to call home and I'm going to ask your parents. And if they say, I'm sorry, you can't talk to them, they're in their room doing math, I'm going to be angry. No doing math. Awesome, guys. Thank you very much. It was nice to see you. Nice to see, the top third of your faces.